Imagine you're lost at sea. Your only hope? A compass. In the vast ocean of machine learning, metrics are our compass. They tell us if we're heading in the right direction. Metrics measure a model's performance. Accuracy, precision, and recall are just a few examples. Collecting these metrics efficiently is crucial. Why? Because training complex models takes time, a lot of time. Inefficient metric collection adds delays. These delays slow down our progress. Think of it like this: you wouldn't want your compass to take an hour to point north, would you? No, you need it to be fast and accurate. The same goes for metrics in machine learning. In this exciting journey, we'll explore how to collect metrics efficiently in PyTorch. Fasten your seatbelts and let's dive in. Imagine you have a race car. It's fast, but you know it can be faster. How do you find out where to make improvements? You use a profiler. A profiler analyzes your car's performance in detail. It tells you which parts are slowing you down. In the world of PyTorch, we have the PyTorch Profiler. This tool acts like a mechanic for our code. It helps us identify performance bottlenecks. These bottlenecks are like parts of our code that are slowing things down. The PyTorch Profiler provides a wealth of information. It shows us how long each operation takes. It helps us understand memory usage. With this knowledge, we can optimize our code for maximum speed. Just like a race car needs regular tuning, our PyTorch code can benefit from profiling. By identifying and addressing bottlenecks, we can make our models train faster and more efficiently. Let's meet our star player, ResNet 18. It's a convolutional neural network. It's like a powerful brain designed for image recognition. ResNet 18 is relatively simple, yet it packs a punch when it comes to performance. Don't let its toy status fool you. ResNet 18 is widely used in research and industry. We'll use it to demonstrate the impact of metric collection on runtime. Imagine ResNet 18 as a chef in a kitchen. If the chef has to walk miles to fetch ingredients, cooking slows down. Similarly, if metric collection is inefficient, ResNet 18's training suffers. By optimizing metric collection, we can help ResNet 18 reach its full potential. We'll make sure it spends more time learning and less time waiting. Time is of the essence, especially in machine learning. Let's measure how long it takes to collect metrics with ResNet 18. We'll use a simple timer. This timer will record the time before and after metric calculation. We'll train ResNet 18 on a small dataset. This will give us a baseline for comparison. Then we'll introduce different metric collection methods. We'll observe how the time changes. This experiment will highlight the overhead associated with metric collection. We'll see that even small inefficiencies can add up over time. Remember, every second counts when you're training complex models. By measuring the metric cost, we can make informed decisions about optimization. Section 5, PyTorch Profiler in action, spotting the bottlenecks. Remember the PyTorch Profiler, our code mechanic? It's time to put it to work. We'll use it to pinpoint the exact locations causing slowdowns in our metric collection. The profiler will show us a detailed timeline. We'll see how long each operation takes within our training loop. This includes data loading, model forward passes, loss calculation, and of course, metric collection. Bottlenecks can occur in surprising places. Maybe our metric calculations are too complex. Perhaps we're transferring data unnecessarily. The profiler will reveal all. Armed with this knowledge, we can target our optimization efforts effectively. It's like having X-ray vision for our code, allowing us to see what needs improvement. Section 6. Streamlining for success optimization strategies. We've identified the bottlenecks, now let's fix them. Several techniques can help us optimize metric collection in PyTorch. First, we can reduce data transfers. Moving data between the GPU and CPU is costly. We'll explore ways to keep metric calculations on the GPU. Next, we can simplify our calculations. Sometimes we might be using overly complex formulas for our metrics. We'll look for simpler, faster alternatives. PyTorch offers optimized libraries for common operations. We'll leverage these libraries to speed up our metric calculations. Finally, we can parallelize our code. If possible, we'll compute metrics concurrently to save time. This is like having multiple chefs in the kitchen working together. By applying these optimization strategies, we can significantly reduce the overhead of metric collection. Section 7. The need for speed. Benchmarking our progress. We've made improvements, but how much faster is our code now? It's time to benchmark our progress. We'll compare the runtime of our original code with the optimized version. We'll use the same dataset and training parameters for a fair comparison. This will clearly show the impact of our optimization efforts. The results will be exciting. We'll witness a substantial reduction in training time. This means we can iterate faster, experiment more, and ultimately build better models. Benchmarking is crucial to demonstrate the value of our work. It provides concrete evidence that our optimization strategies are paying off. Section 8, Beyond the Horizon, Advanced Profiling and Exploration. Our journey doesn't end here. The world of PyTorch performance optimization is vast and ever-evolving. There are always new techniques to learn and explore. Advanced profiling tools can provide even deeper insights into our code's behavior. We can delve into memory allocation, kernel execution times, and more. Additionally, the PyTorch ecosystem is constantly evolving. New libraries and tools are emerging, offering even more powerful ways to optimize our code. The key is to stay curious and never stop learning. By embracing a mindset of continuous improvement, we can push the boundaries of what's possible in machine learning. Section 9, Conclusion. Mastering Metrics for Machine Learning Mastery. We've reached the end of our adventure in efficient metric collection. Just like a well-calibrated compass guides us to our destination, efficient metrics guide us to better machine learning models. By understanding the importance of profiling, utilizing tools like the PyTorch Profiler, and implementing optimization strategies, we unlock the true potential of our models. Remember, every millisecond saved in training time translates to faster iteration, more experimentation, and ultimately, more successful machine learning endeavors. So go forth, optimize your metrics, and may your models always train at lightning speed.